Hey everybody, welcome to Spacecast. I'm Josh. Today we're going to be talking about some interesting things with some of our guests here. Typically what we do in Spacecast is we talk about the aerospace and defense industry, and today we're going to be talking about the very early parts of the aerospace and defense industry, mainly the building of the systems that everyone operates. So today we have Joshua Edwards, who is from Phoenix Integration as Senior Systems Engineer, and Jeff Baxter, who heads up our engineering department. Welcome, guys. Thanks for being here.
Yeah, thanks for having us, Josh. It was good to have you on the web or join the webinar beforehand. And
hot off the presses. We just finished a webinar moments ago.
Yep.
And there wasn't quite enough time in the allotted slot, so we wanted to do this video. And thanks for coming around, sticking around.
Yep.
And going into a little bit more detail about some of the topics that we wanted to cover in that webinar, and we'll just cover them here. So. The main thing we're going to be talking about is on this slide and the TV behind us. It is the combined and integrated persistent model in the digital engineering ecosystem. Is there a better way to say that, Jeff? Or you?
No, I mean, I think you nailed it. We call it the digital mission engineering ecosystem.
There you go.
And really what we're trying to show in this webinar is how you can use this new approach to more quickly and rapidly develop more complex systems through modeling, simulation, and combining all these tools with the concept of a digital thread that links all the tools together. And what I wanted to do here, as part of the webinar series, we've been working on some demonstrations that show how all these tools integrate together. And with Joshua here, I've already learned a lot about how you use Model Center to link all the tools together. And so he had some good advice for me as I was putting together the demos with some of the other engineers here at AGI, and I thought that, hey, this would be a great opportunity to get some of those insights and that you've learned along the ways that we can share with the rest of the world here as well.
Yeah, very cool. And so you guys are each respectively leading up the integration of some of these tools for your companies.
Yep.
Very cool. So we're talking about integrating lots of tools and STK and Model Center and more. And as it's a tall order to do. I mean, there's a lot of different moving parts here. So what's your approach to these models in general? Like, where do you start to get all this stuff to talk to each other?
So I guess I would say I would go back to the kind of the archaic whiteboard. As silly as it sounds, I think it's shown time and time again that it's very helpful to get everyone's ideas out. You have all these tools, you don't know exactly how they fit together, you don't know really how they work together or what they're going to be passing. So I think the first step is just getting it out on the whiteboard. Having an idea of what is your main goal, what do you plan on doing, what features do you want to see in there. And I've sat down with customers in sessions before and just literally not really done too much integration at the beginning, but mostly just being the whiteboard operator.
I can handle that position.
Yeah, it's not too bad.
And I know, speaking from our approach working together, that's been really helpful because here at AGI, I'm so focused on the SDK piece, and I have a good sense of what I want to show in SDK. But then when you have this larger demonstration that integrates Excel and Cameo and ANSYS products, and including CAD files, like how does it all play together? That has been very helpful to go back to the whiteboard to say what goes into each model, what goes out, and how do they all fit together. So that's definitely good advice.
Yeah, completely agree. Yeah,
just to not to roll back tape a little bit, but the picture that we referenced before that is behind us, and it will be behind us for this discussion. This sort of is a depiction, originally drawn on a whiteboard, of the big system from the beginning to the end, designed through operations and around the horn, keeping going. Jeff or Joshua, can you just talk about this real high level in case anybody out there didn't see the webinars, what we're looking at, what's behind us, what the grand vision of all this is going to be?
Yeah, absolutely. So the main, just in a nutshell, that we're looking at is the program lifecycle, which is typically seen as a V, but we're representing it more as an oval. So you're starting with a mission objective or a mission need that results in the need for a system or a program. And that typically starts with the government identifying some critical mission need, and then they'll put out a proposal that industry and contractors will then bid on, and then one or many will win that, and then eventually they'll start developing the system. And so we're showing that process from concept development to system level design to detailed engineering and component design, all the way through testing, operations, and sustainment. And what we've seen at AGI over the last 30 years is there's not always a common environment to model the physics at each of these stages. And there's a lot of times custom tools that do a specific niche in a certain area. And there's a lot of reinvention and duplication of effort along the way. And so what we're showing here is a complete circle that has all those models integrated, ideally from day one all the way through the end of the program, that is rooted in that multi-domain physics environment. And as you change certain parts of one model and see how that impacts the rest of the larger model. So that's what we're showing in this webinar series. It's it can be complex as the systems get complex, and what we're showing is kind of a notional example, but it talks to some of those key points. And we're on series 3 of 4 in the webinars, and we've so far integrated STK, Excel, and Cameo through Model Center, and the next one we'll talk about ANSYS as well.
Just to put in my 2 cents, I think this is a great vision, and even the slide before this where you're kind of describing the current state where you have these disparate models that are used in one piece of it, and then kind of scrap that and use a different model for this piece and then a different. I feel like I see that time and time again when we approach customers or customers approach us on discovery, trying to figure out things, and this is some of the stuff that they're trying to alleviate, where they say, we have this whole process at the beginning for acquisition, but then that gets through, and then next thing you know, they're off doing a second project once they win the bid. So I think this schematic tells a great vision or a great story from the beginning of the current state up into what it should be.
So part of that state I can see on the chart is the modeling the mission from the beginning to the end as the mission model. Jeff, can you go into the brief version of that?
Yeah, so the mission model.
And what you mean by that?
Well, yeah, so what we really mean by that is the STK piece is been around in the last 30 years to solve mission problems. So defining missions, simulations, evaluating measures of mission effectiveness, and we have a tool STK, that systems toolkit, that allows you to model that across any domain, land, sea, aerospace. And so that's where AGI has spent a lot of time in the industry over the last 30 years, is working with customers on their mission model and how do you represent their system inside of STK and perform analysis and understand the impacts of mission effectiveness. And so what we're doing here in this larger webinar series is expanding the view beyond just STK to the larger ecosystem of tools and processes for throughout the whole engineering process. And so that's kind of opened my eyes into, all right, you have to consider all these other tools as part of it, the CAD model, you have to figure out the detailed engineering simulation, the CFD runs inside of ANSYS, all of that stuff that typically is outside of STK. We're now starting to help expand the view of that for ourselves and for our customers.
And you could say it's kind of been a long time coming because, like you said, Systems Toolkit is what STK stands for, but in the old days, it started as Satellite Toolkit.
Yep,
and then we realized that satellites were a part of much larger systems and ground ground vehicles and air vehicles. And so a number of years, even before the name changed, that was true. It was a Systems Toolkit. And I remember the time when we decided to rename it, we're like, well, it makes a lot of sense because that's what it does. So, and that was STK 10, I think it was. And that was probably... we're on 11.6 right now. 11.7's coming out soon. So it's been a while.
Yep.
Sort of positioning that and learning this stuff, like you were saying, and going in this direction.
Yep.
So another tool that I've heard about, and this is more for the descriptive model, and I don't know much about it. Maybe you guys could go into a little bit. Is a tool called Cameo, and what does that bring to the big oval behind you?
Yeah. So I don't claim to be a SysML expert, and so to distinguish, Cameo is the tool that NoMagic provides. The language that it helps the user facilitate is called SysML. So what we've seen over the last few years with SysML is a huge spike in interest. I remember when I first started my career, we had MBSE Pack and we were presenting it to customers, and they just, you could tell it wasn't there yet. Like, they didn't see the vision yet. Mm-hmm. It is definitely, like I said, spiked in the fact that everyone is seeing that this is a way, these tools like Cameo are able to capture the complexity in these huge systems. Model Center has a way to kind of capture the physical analysis or the physical behavior or the engineering analysis for things, but then there's all these extra bits in there, such as requirements and how things interact with each other. How are they comprised of each other? How do they work in a behavior? And that's what Cameo has kind of come in, or SysML tools like Cameo have kind of come in and said, we have all these complex systems that we're working with. No one can keep this in their head. And honestly, the traditional way, it was document-based. So pretty much everyone would write it down on PowerPoint or Word, but then once you updated one value somewhere,
right. It's a lot of editing to keep up with.
Yeah. You'd have to literally go through each page and update that one value. This is essentially moving the same way that CAD moved from the drafting table to CAD tools such as NX or Creo. This is essentially moving the documentation process into the digital world.
Very cool. And we kind of breezed over it a little bit. Can you real quickly talk about Model Center in this big loop here too?
I would love to.
Close to your heart.
I've been using Model Center for probably going close to a decade now. The application of it and what its main purpose is it's a framework for integrating engineering analyses. So what we usually say is, we don't do any of the engineering analyses ourselves. We're not here to compute your thermal load or do a cost analysis. We're here to be the framework that integrates them all. And from what we've seen, we're kind of one of the higher, players in the table of doing this, and the fact that we don't really tie to a specific vendor or suite of tools or anything like that. We're happy to take all tools, whether it's your in-house codes or COTS tools, integrate them into a workflow, have them connect with each other so that they're passing data, and make them fully integrated so that you have this multidisciplinary process that is no longer saying, I'm going to focus on electrical, do my analysis, and then maybe pass my results down to mechanical. You're now putting them all into the same room and having them work together, very similar to taking engineers from disparate, departments, putting them in a room and saying, work on this project together.
So kind of the mindset of people that make STK, AGI, and Model Center is like you're coming from that integration perspective from the beginning. So it makes a lot of sense leading the charge with you guys doing that in this whole digital engineering thing, because it is going to be on my microphone just came out. It is going to be a lot of integration between these tools, and your mindset from the beginning has always been to integrate tools and see that larger picture.
Mm-hmm. Agreed. One little thing to that is some of the customers I have seen or the trainings that I've give, customers or engineers don't always see it in that way, that they know that their tool is going to have to integrate with something else. A lot of times we get a lot of one-offs, and even the mindset that users have is that all they really need to do is set up their one problem, click the play button, it gives some results, and then their job is done. The biggest hurdle most of the time we see in trainings and all that is to get people to think in a flexible, integrative way to know that you're not going to be the only piece of the puzzle. What you're presenting is going to be consumed by someone else, and you need to work together. So not only are you kind of integrating the tools, you're integrating the people to collaborate and work together.
Yeah, and that's what's been helpful for us putting this webinar series together, because I know personally I had never even used Cameo before, and so part of the benefit of having you join us for this and working with Phoenix in general is you're not experts in any of these tools, but you're familiar with them, and so you're able to point us in the right direction. We're able to take some example Cameo models, and then we're able to take our expertise and knowledge in STK and then create a similar SysML model from there, and then put together a pretty compelling demo in a very short amount of time. So yeah, that's been valuable for us, is getting that exposure to the broader suite of tools, and focusing outside of just STK, but getting into CAD models, getting into ANSYS products, getting into Cameo, and SysML in general. It's been very helpful.
So let's talk about ANSYS for the engineering simulation. It's on the chart up there. Can somebody talk about how that plays in?
I guess
a high level, and then I'll.
Well, I guess a couple of things to highlight. ANSYS is our next webinar coming up, and as part of that, we're going to be integrating different demonstrations from STK and ANSYS. We have a few different models that are kind of separated, where we've worked with ANSYS on sending them data files inside and out, or to them.
Can you do a high level what ANSYS does, what they bring to the table?
Yeah, so they're focused on engineering simulation, and so they're very much in the component level design, the high fidelity engineering, detailed engineering part of the life cycle.
Like CFD and
things like
CFD, at that level.
Yeah, thermal analysis, structures and structural analysis. So the main areas that we integrate well with them is their mechanical product line, their electronics product line, and fluids product line. Those are some of the main areas of synergy, I guess, if you will. And so we got a recent partnership. We're starting to work with them, and as part of these webinar series demos, we want to integrate ANSYS here. So I guess my question is also in the how. So I'm curious if you have any experience and what your general advice is as we start putting these demonstrations together. We have STK files and ANSYS files. So how do we kind of bring that all together in an automated fashion? How do we verify requirements through Cameo as part of that overall process?
Yeah, so I've worked with ANSYS a little bit. I, once again, don't claim to be an expert.
We have you on video saying you're expert earlier.
Yeah.
So just kidding.
But for the most part, just to take a step back with a lot of these COTS tools, especially like ANSYS, at one point, so I've been told, I wasn't that old apparently, a lot of these programs used to be file I/O only. So, you're opening up a command line, you have a little text file, you tell the command line, okay, run this executable with this input deck, and it's going to spit out this output file. Believe it or not, a lot of these tools still kind of work with that behind the scenes, even though they all have nice shiny GUIs, which makes user experience much nicer. We actually still use that back end. So as far as integrating ANSYS, we still are able to, and I've worked with ANSYS engineers, and they've provided me files that hey, here's my script, or my it's a little bit more complex now than just a quick little text file, but what they call a journal file that kind of tells the project how to run or what it's looking for. So that's essentially our input file. The executable, of course, is their executable that you launch when you run. And then the output file, more than likely in that journal file, you can essentially say output to this directory or this result. So what we do is essentially take advantage of that and use that. And with one of our tools in Model Center, one of our plugins, Quick Wrap, we point to the input file, the journal file, and we point to the project. We tell it how to run, so we need an executable with batch commands or whatnot, arguments, and put that all in our tool, exposing the inputs and the outputs that we're interested in, and then kind of commit that to the model. And if all goes well, everything works. And of course, the first line of defense on that is kind of to take Model Center out of the equation. You would think that I'd be all gung-ho about getting it in Model Center very quickly, but what we usually try to tell customers is to kind of keep out Model Center until you have your analysis down. You know that it can run without having any issues, because once you add it into Model Center, now you're just adding an extra layer of complexity of debugging. So once you can kind of get that whole process down, which is kind of the next step after whiteboarding that we were talking about earlier, is to get things running manually. Okay, identifying all those prerequisites. Once you have that down solid, it's pretty simple to just kind of plug and play with Model Center. But it's all the legwork and all the lifting up front that's the difficult part.
And do you have those quick wrap scripts built for all ANSYS products? So I mentioned mechanical, electronics, fluids. Are things kind of pre-built for those, or how would I go about actually integrating my STK scenario that has, the solar flux coming in from the sun on a satellite over time, and then I have an output report in STK that has a time-based value for all of the fluxes on each face of the spacecraft. I can generate like a CSV file, for example. So how would that go about integrating with Model Center?
Yeah, so of course we can do, as we've seen, we can integrate STK. And as I just kind of loosely described, we can integrate ANSYS. Then it becomes of getting those two to talk, because until we start passing data, they are just disparate models. They don't know the other one exists. So then it's identifying those inputs and outputs. Okay, what is the output coming from STK that ANSYS is expecting? Also, is it in the correct format? You're saying CSV file. Does in this specific use case, does ANSYS accept a CSV file for this engineering analysis? Or maybe it might only take a single array, or maybe it only takes the last value. We have tools to kind of identify that and to help kind of parse the data from one tool, reformat it or pass those values into a format that the other tool can accept. Okay. And then as far as, kind of the scripting and things like that, it's all completely dependent on the use case, where, we're not generating anything. We're essentially relying on that tool to be interoperable, and to the end user to know how to manually run that program. Once they're able to do that, then it's, like I said, pretty short and simple as far as plugging it all into Model Center.
Okay.
You touched on scripting. I know that there's always going to be some level of scripting required in these integrations. And can you go over? You can have a couple pictured up there. I can see MATLAB and Excel sort of as a scripting, can be treated as a scripting tool. Can you guys touch on that a little bit? Because I think something that's near and dear to most engineers' hearts is some level of scripting integration that they do or like to do or have to do.
Mm-hmm. The customers that I talk to would wholly disagree. They hate scripting so much. They don't want to ever touch it again. I get to trainings and we do have some tutorials where we're saying, okay, write this quick script and then throw it in as part of the workflow. And that's the worst part of their day.
That's what they don't want to do.
Yeah,
Okay.
Exactly. But we try to make it easy with certain languages, for instance, VB script, Java, Python. We allow a certain file format called a script wrapper, where you can go and specify that scripting language. And so if you already have an existing script, you can essentially copy it all, paste it into that script wrapper with some additional headers and variable declarations and all that Model Center understands. And so essentially when it comes to that, becomes a black box. And when Model Center gets to that component to execute, it just executes as if it were, running the script natively in whatever language it's in. It all usually depends on the script, and even I have to go, to Google every once in a while and go, how do I write this in this language or not? So yeah.
Nice. Well, for the record, I enjoyed scripting, but it was only when it worked, which was rare. So.
And I'm curious, just because you have integrated and worked with so many customers and integrated their tools, I'm curious what your experience is with the types of tools that are most common that you run into. I'd say at AGI, we get a ton of MATLAB users, large majority. Over time, it has been a lot of scripting we've been seeing in Python that's been growing in popularity a lot. I know there's different IDEs for Python like Anaconda. And so can you talk to a little bit about Python, both in the common scripting languages you see, and then also some of the either challenges or best practices for using IDEs like Anaconda, or do you, within Model Center, is the script wrap functionality, does that take away the IDE of choice?
So let me just see where to start here. So with Python, I completely agree that I see Python, getting more popular and popular every day. We actually ship a version of Python that comes native. I believe at the moment it's like 2.7.4. At the time, that was kind of state of the art, and then now, of course, they're in the threes. I'm not even sure where they're at now. And so we constantly get requests, and especially of these other IDEs like Anaconda, and I think there's Active Python. So if it is in the version language that we support, it's mostly just copy and paste it in, and what we'll do is work with our instantiation of Python to execute that. Now, not everyone uses 2.7.4, so that's when we have to start being flexible. And we have that quick wrap utility where you can essentially specify the IDE or the executable that is going to run the Python code, and then specify the script almost as an input file. So very similar to what we were talking about with ANSYS, where it has an input file, an executable argument, and then an output. We can kind of do the same thing with Python as well.
Okay.
And in the future, I want to say, and my development might kill me for this one, is I think we're looking to make that even more flexible down the road to where we're not locked into a specific version. We try to help facilitate any version that people are using.
Is that specifically for Python or for other languages as well?
That statement is specific for Python, just because we are
the growing popularity.
Exactly. Yep. Everyone's using it. I've seen customer lists of these are all the versions that we use of Python, and you would think it'd be like, oh, it's just this one and that one, but no, it's 3 pages long of all the different branches and all the flavors of Python that you see as well. So we're trying to heed that call and trying to be as flexible as we promise to be, and allow people to just kind of throw it in and it work.
I had a question about CAD models. You had mentioned the drafting tables and going the next level and doing the same thing for documents for this. Mm-hmm. Can you talk about how the CAD model integration works in this ecosystem?
Yeah,
just a little bit. And
I had a question on that too, because STK it doesn't really use CAD files directly. We use Collada files, GLTF files, which are like the outer mold line, because we don't care about the nuts and bolts necessarily for all types of analysis in STK. So it's a little bit new to us, but we are, especially with ANSYS products, they are all built on CAD, and having that higher level of fidelity to do as installed antenna pattern analysis and other things. So I'm curious how complex your models in Model Center have gotten using the CAD geometry to parameterize that CAD file and change inputs like you would in SDK, but for a CAD file that has many facets and geometry. So I guess just describe the overall process and how, what if you have multiple CAD files, what's the most complex model you've built with CAD files, I guess is my question.
Is it going to be cliche if I say I'm not an expert in this? No. So to back up, to kind of answer both questions at the same time, currently in Model Center there are 4 plugins for CAD. So I'm going to have to remember this: NX, Creo, SolidWorks, and CATIA. So what we noticed when we created those is those were the 4 main tools that our customers were using. So we went ahead and developed plugins for it. And to say when I say create plugins, essentially they have an API that we code against, and we actually pay royalties to those tools to include them as plugins. So to take that the next step further, what if you don't have one of those tools? I know that wasn't a question asked, but I'm going to touch it real quick. So in my undergrad research, I used a tool called Rhinoceros 3D, which is very heavy in the kind of ship design sector. And so they even had, of course we didn't have a plugin for that, but it was my job to actually script the automatic generation of a geometry in that tool. And so that was all about looking up their API. They actually have their commands sitting on top of VB script, so they called it Rhino script. And with that, we were able to kind of integrate that, just using that as a scripting language. So that kind of ties back to the whole scripting discussion we had before. So just by doing that, we were actually able to automatically generate geometry, parameterized geometry, I should say, just by scripting out a few commands here and there. Now, moving on to the complex ones that we've seen, It seems that every day I see something more complex where I think, oh, it's, this was the most complex I've seen. And the next thing I know, this is the most complex I've seen. Being the fact that I'm not an expert means that I'm constantly going, oh, wow, that's a big model. That's a big CAD model, I should say. When it starts getting, in my mind, the most recent complex thing I've seen is, an assembly of multiple parts, and then being able to select a part. So for instance, some aspect of it that already has a set geometry to it that you can swap in and out for a different type. And being able to essentially say, oh, I want part 1 to be here, and everything just works as is. And then on the fly in Model Center, being able to, change that string to the different, part number 2, and it goes actually and proactively goes and grabs the new part, which was in there all along, but more of kind of makes that active and deactivates the other one. So that's the latest one that I've seen be complex, and I was pleasantly surprised to see that our plugin handled that without too much of a hiccup. It was mostly just setting the options in the tool to make sure that it was read correctly, and when I say the tool, I mean the CAD tool, that all those subparts were behaving correctly. But once it was in Model Center, you could essentially change any parameter you want, and that have a visual of that geometry change on the fly.
So how about the most complex in terms of number of tools you've seen in a workflow in Model Center?
Ooh, yeah, that always varies. Sometimes we get into people are using MATLAB, Excel, and Python, and that's their bread and butter. That's all they want to use, and that's all they currently have to use. And then you get others that kind of will grab, it seems like, every tool that there possibly is. But a common thread usually kind of seems that it kind of starts out with, a CAD tool or some kind of tool at the beginning to kind of define the geometry. Moving on from there, I'm thinking in terms of, a Model Center workflow, because this is what I've seen. Moving down to some kind of, in one case I've seen where they wanted to export it out into a different geometry format, for instance. You're talking about those different kind of like parasolids and shrink wraps and things like that. Doing that and then moving down even further, you get options to either do, a FEM, so you can do CFD or a structural analysis on that. And then it usually kind of takes on the use case of, okay, what are they trying to accomplish? Does it then move into MATLAB as a post-processor to kind of run that, simulation with that file or with that, geometry and with those parameters? Or does it move into some other post-processing to kind of look at like what the max stress is, and that's, good enough? It's just a beam equation or something like that. So it varies all around. But yeah, usually that's kind of the template that we see, and I can't really put a number on number of components we've seen. I know they can get rather hefty, because you're trying to capture all this and automate a manual process. And to do that, you got to capture a lot of that knowledge in individual components.
Yep. Okay.
So it actually brings up a question in my head, and I don't know if it's a question or more of a statement, I think the CAD example is representative of integrating between models of different fidelities. So you have your specialty tools in this big ring that does something very specific, like CAD modeling down to the screw threading on the wings of an aircraft. Because, STK doesn't care about the bolts, the threads and the screws and the wings. It just cares about the wing and things like that. And what are the thought processes, or what's the philosophy on going across those different levels of detail between the models?
Yeah. So an informal kind of methodology that we use with our customers is kind of crawl, walk, run. So start with, very high level, I should say low fidelity models that kind of mimic the functionality you're looking to use, and then get it just to kind of a basic workflow integrated together. It doesn't have to have every nut, every bolt, everything. We just want kind of more like back of the envelope calculations. Then from there, with Model Center, you're able to swap in components in and out or put conditional statements. So we could have a branch in a workflow that says, based off a string I set, low, medium, or high, we're going to run this model if I put low. So that's going to be quick running. It's going to get us the general answer. Maybe we have a little bit more time, or we've narrowed down the focus of what we want to do. Maybe we want to switch that over to high fidelity, where that might, execute on an HPC. That might take, a weekend to run, something like that. But you don't want to be running that every day, every time, trying to figure that out. So I think it's a matter of, like I said, that crawl, walk, run, where you start off simplistic and then slowly adding on capability or fidelity. And then the other thing is, what if certain tools accept this or don't accept that? You can allow the passing of whatever data you want. So if, as long as the downstream tool does accept it, you can pass anything that you want there. If another tool accepts some other, list of parameters that are different than the first tool, you could send those completely separate. So it doesn't have to be an all or nothing kind of approach.
Well, thank you guys for taking the time to talk today. I know you just did a whole webinar, and we've talked another 40 minutes almost on this topic. This is a webinar. The other ones are webinars. And you have one. You like that one, Jeff?
You might want to edit that one out.
No, I'm leaving that one in.
Are you going to leave that in?
I'm going to leave it in.
All right.
It's going to be the slogan from now on.
Yeah, webinars and webinars. I think it's sticking. Real quick before you leave, what's your favorite space movie? Or you can say airplane movie too.
Star Wars for sure.
Of course.
Star Wars and Top Gun. It's not even
all right, that's
at least mine.
Solid answers.
I don't know. What do you think?
That's a tough one. Unfortunately, I know
I'm in Star Wars.
Unfortunately, in this video, I'm saying this wrong. I'm not a huge space nerd. I'm more of a ship nerd.
What's your favorite ship movie?
Not Titanic.
That was all right. It was good.
I had a professor in college who actually did a whole thing about Titanic, and especially the visuals on it, that the ratios weren't correct when they tried to CGI the waves coming off of it. The ship was way too big. They weren't doing the correct scaling, using the Froude number to actually generate the waves. So if you look at once you see that and you look at the ship going through the waves, it just
ruins it for you.
It looks completely wrong. It's like the ship should be producing way bigger waves than that.
I'll never watch it again.
Yeah,
Yep.
Me either.
Good to know.
Great.
You just ruined it for me.
Jeff, what are you going to do tonight now that you can't watch Titanic again?
I don't know.
Well, thank you guys, and thank you for the webinars. And we got one more going, and they're always going to be available at agi.com/DME if you missed them live. It's great to get them live because you can get your questions in and get your questions answered by these guys or some other engineers who might be in the room. But we have one more coming up, and that's it for now. So,
All right. Thank you.
Thank you.
Thanks again, Joshua.
Yep.